Today we will discuss some of the organic questions asked in past papers. So this is the first question in which they are asking about the different functional group present in the compound, right? So the main functional group here is NH2, carboxylic acid and alcohol. OH group is there, COOH and NH2. NH2 is amino group and not nitro. Nitro is NO2, right? Here option A and C, which is given as nitro, so these are not the correct options. So answer should be either B or D. Carbonyl is C double bond O, carboxyl is COO. So when compared to B and C, amino group is there, NH2, hydroxyl OH is also there, but the third functional group is carbonyl, is given in B option, but it is nothing but carboxyl. So option D is the correct answer. Okay. Second question, which is about the homologous series. They are asking about which compounds are members of the same homologous series. In the first compound, it is propanol, which is aldehyde, propanone, ketone, propanoic acid, carboxylic acid. All three functional groups are different, so they are not corresponding to same homologous family. Second is propane, propene, propyne. Though all of them are propane, but the functional group is different. So this is also not the correct option. Whereas in the case of third, which is a positional isomerism, though all of them are alcohol, but they are different in position. 1-ol, 2-ol and 3-ol. Right? So homologous series is a family of compound having a same functional group at the same position. So option 4 is the correct answer. Next question, which is about the conversion of propanol to propanoic acid. The different options are given. Lithium aluminum hydride is usually added to reduce, right? It is not an oxidizing agent, it is a reducing agent. So if you have an idea of oxidizing and reducing agent, you can neglect option B and option D. So A and C would be the, you should have to choose either A or C. So reflux with acidified potassium dichromate will give you alcohol to propanoic acid. So this is the correct option. Next question, which is question number 4. The question is about identifying the electrophile and the type of reaction, which is again very important question. Most of the question papers are having this question. So here the electrophile, the reaction is between benzene and NO2 plus. NO2 plus, which is the electrophile. You know what is called electrophile and what do you mean by nucleophile. Any species carrying positive charge is an electrophile. That is the first identification. So you can neglect option C and D. So A or B would be the correct answer. When comparing A and B, you can neglect addition reaction. You know that the reaction is for benzene. Benzene undergoes only substitution reaction, which is different from the regular unsaturated compounds. Usually unsaturated compounds undergo addition reaction. Benzene, the double bond is not like a usual double bond, which is different. We have studied already. So this undergo substitution reaction. So option A is the right answer. Next question. The question is about the intermediate formed in the reaction. So this is an example of electrophilic substitution reaction. Just now we have seen. So it's a benzene derivative. I already explained in the first series, in which NO2 is a nitro group, NH2 is a amino group, right? So the product is conversion of NO2 to NH2. So oxygen to hydrogen. So obviously it is a reduction reaction. Reduction is nothing but addition of hydrogen or removal of oxygen. So this is an example for reduction reaction. The question can be asked in that format also, whether it is an example of oxidation reaction or reduction reaction. Next one is, what would be the intermediate formed in this reaction? Obviously it is not it is not with NO2 plus, NH3 plus. This would be the intermediate in which NaOH reacts, liberating water molecule, resulting in the formation of NH2. So B is the correct answer. Next question. The question is about E and Z isomer. E Z isomer is not in the syllabus, but the question can be asked in terms of cis-trans isomerism. Right? E isomer is similar to trans, whereas Z is similar to cis. So though the question is about E and Z isomer, this can be related to cis and trans isomerism also. In this case, you just have to identify the unsaturated system, which is C double bond C. Locate the C double bond C in the isomer and then find out whether the groups attached to the C double bond C are on the same side or on the different side. If the two groups attached to C double bond C system on the same side, it is a cis isomer. Whether the two groups are on the opposite side, it is a trans isomer. You can clearly see this is the C double bond C system in which hydrogen is located on the opposite side. So it is an example for E, or I could say trans. You just check out here. Here all three groups are different. So you could not predict whether both of them are cis or trans. In that case, you should have to number it. Like methyl group and hydrogen group, you know, the more atomic number will give you a higher priority. In this case, methyl group will have the higher priority. Hydrogen would be number 2. In the opposite side, in one side you are having ethyl group, other side you are having methyl group. So obviously methyl would be the number 2 position, and ethyl, which is having a higher priority because of 2 carbon system. Here it is only 1 carbon system, so it is number 2. Now you just check out, instead of group, you just check in terms of numbering. These two numbers 1 and 1 are on the opposite side, whereas the two numbering 2 are on the opposite side, which again tells you about the E isomer. So the answer would be AA. Though E and Z is not given in the syllabus, the same question would be asked in terms of cis and trans isomer. So the answer would be trans and trans. Right? Next question is about NMR spectroscopy, right? So you just have to find out the type of compound associated with this spectra. So by looking at the spectra, you can have a clear idea. The compound should have 3 different type of hydrogen atom. So the number of signals directly tells you about the type of hydrogen atom present in the compound. Just write down the structures of these. Propanol, which is CH3, CH2, CHO. This is the structure of propanol. Propanone, CH3, C double bond O, CH3. This is propanone. Propane, which is CH3, CH2, CH3. Methyl propane, in which one of the hydrogen atom would be replaced by methyl group. So by looking at the structure, you have one idea that this acetone, which is having a similar type of hydrogen on both ends, so it will give you only one signal. And in the case of propane, which again there are only two types of hydrogen atom, methyl hydrogen atom and CH2. So you can neglect propane and propanone from this answers, and the option would be either A or D, right? A, you are getting CH3 proton, CH2 proton and CHO proton. In the case of methyl propane, you are getting CH proton attached to CH3. This is also again giving like two signals. So the answer would be directly you can choose A is the correct answer. Next question. The question is about mass spectroscopy. The mass spectra is given with the M by Z value. You just have to find out which compound corresponds to this mass spectra, right? So first find out the atomic weight of all these compounds, mass of all these compounds. If you calculate it, you will get this is about 63 or 64 and this is 63. These two compounds possess an atomic mass of 60. So you can neglect A and D because the last value which corresponds to the mass of the compound. So it clearly tells you the compound which possesses 60 is the correct compound, but the option here is B and C, both of them are having 60. So you just have to find out the fragmentation pattern of other peaks related to the compound, right? 15 which corresponds to methyl group I told you, so methyl group is present in both the compounds. Apart from that, you could look out the molecular ion peak which is present in 43 and 45. Both of them are having high intensity peak. 43 which is 100% which is molecular ion, and 45 is also having a high intense peak. Those two peaks are supports the structure CH3 C double bond O, which gives a peak at 43, or COOH, the other compound, which gives a peak at 45, and so all these values which is present in the peak supports structure C. I think you understand the concepts. So option would be C. Thank you.